In today's lesson, I'm going to do how to find the area using area and definite integral. So I'm going to do a couple of examples here. So the first example here is there is a graph of y is equal to f of x. We don't know what is the function, but it's y is equal to f of x. It consists of line segments. The one is 0 to 4, and then you have another one going from 4 4 to 6 negative 4, and then you have another one from 6 negative 4 to 8 negative 4, and then from 8 negative 4 to 12 4, and then you have another line which is x is equal to 12. And now what you need to do is you need to find 0 to 12 f of x dx using geometrical formulas here, and you cannot use a calculator in this case because the function is not known. Yes, you can find the value of the function for each segment, and then you can evaluate how much is the area. But rather than doing this, because in the question they ask you to find f of x from 0 to 12 using geometrical formula, so we have to use that. Now to find the area, let's say this is area A1, this is A2, and this is A3. So the area is going to be A1, and then this area you will get a negative, which means we need to do minus A2 and then plus A3. And now A1, the area A1, as you can see, this is a triangle, and the area of a triangle is half times base time height. So this is going to be half times, now here this is 5, and height of this triangle is 4. So that gives you 10. And then A2 is going to be, this is trapezoid. So the area in this case will be half times, the formula is half A plus B times height. Now here, the difference between here, between 6 negative 4 and 8 negative 4 is 2. So 2 plus, and then here 5 and 10 is 5. So 2 plus 5, and then multiply by 4. 4 is the height of this triangle. And here, this area is going to be negative. So what we are going to do here is this is half times 4 times 7. So that gives you 14 here. So the area in this case is going to be 14, and then you have A3, which is your area of this triangle, which is a right angle triangle. So half into base in this case is 2, and height in this case is again 4. So the area A3 is 4. Now here, to find the total area bounded by these triangles, as I said earlier, is A1 minus A2 plus A3, and A1 is 10. So 10 minus 14 plus 4, so that is going to be 0. So the area, total area in this case is going to be 0. So in this case we had to do the geometrical approach because the function f of x is not given. Yeah, you can find the function f of x and can find the areas using that also, but we have to do whatever is asked in the question here. Now the next one is few properties of definite integrals which you need to know. The first one is when you have a k times f of x dx from a to b, we can always take k out of this definite integral because k is independent of x. So this is simply k and then a to b f of x dx. And then if you have a to b f of x plus minus g of x dx, you can always separate them. So a to b f of x dx plus minus a to b gx dx. If you have f of x dx from a to a, which basically means a point, which means the area is going to be 0. When you have a to b f of x dx, then you can change it into, you can switch the lower limit and upper limit, but when you switch them, you will have negative here. And always the lower limit has to be smaller than the upper limit, and that's when we have to switch the lower limit with upper limit, if that's not the case. Then a to b f of x dx can also be equal to a, and then we have another c in between, and then a to c and c to b f of x dx. Okay, so this is again a to b, and that's your minus b to a. Now we need to use these properties to evaluate all of these. So first thing is, this is 0 to 3 f of x dx. So 0 to 3 f of x dx is 5. 3 to 4 f of x dx is equal to 2. 0 to 3 g of x dx is equal to negative 6. and you have 0 to 6 g of x dx is equal to 10. And now we have to use these integrals, definite integrals, to find. First is 0 to 3, 2 f of x plus g of x dx. Now here we are using this property as well as this property, the first and the second one. So we can separate them, and then when we separate 2fx, so you can do in 2 steps. So 0 to 3, 2f of x dx plus 0 to 3 g of x dx. Now this 2 will come out of this definite integral f of x dx plus 0 to 3 g of x dx. Now we know the value of 0 to 3 fx dx, which is 5. So 2 times 5 plus 0 to 3 gx dx is negative 6. So that's 10 negative 6, which is equal to 4. So that is the value of the first part. Now the second one is you have to find 0 to 4 f of x dx. Now if I look at the values, it's given 0 to 3 and then 3 to 4. So I'm using this property. When you have a to b f of x dx, you can always introduce a c which is between a and b. So then a to b fx dx is same as a to c f of x dx plus c to b f of x dx. So I can rewrite this as 0 to 3 f of x dx plus 3 to 4 f of x dx. Now 0 to 3 f of x dx is 5 plus 2. So that gives me 7. So that is how we do part B here. Now part C, we have 3 to 3 g of x dx plus 4 to 3 f of x dx. Now to use this property, we need to have a to c and c to b. So whatever is the upper limit of the first integral has to be the lower limit of the second integral. But in this case, you can see that that's not the case. Then I have to use another property here. So I have to interchange the upper and lower and upper limit of the second integral. And when I change it, this is going to be so this one, part C, is 3 to 3. Yes, okay. Now, before that, 3 to 3 gx, I have the property for this as well. A to a fx dx is 0. So this is 0. Now we need to change it. Since we have 4 to 3, we need to do 3 to 4 f of x dx, and that is 2. So 0 minus 2 gives me negative 2. Okay, so we did not have to use the same because you could have done this also, like 3 to 3 and then 4 to 3, but then you can do 3 to 3 g of x dx minus 3 to 4, but then it's not going to match, so don't do that. This and this is matching, which means this is same as so you have, this is a, this is b, a to b. No, you have to do this one, right? So gx 3 to 3 dx and negative 3 4 f of x dx. Now this and this is matching. So this is a, let's say this is c, this is c, this is b. So this is same as you will have a to c, but then you need here positive sign. So this is not going to work. So don't do this way. This is better. 3 to 3 is 0, and then 4 to 3, you reverse this. When you reverse that, this becomes negative, and 3 to 4 fx dx was 2. So that is the best way to do this one. Okay, so the next one is, the next part is here. We have to find 3 to 6. So 3 to 6 g of x dx. So 3 to 6 gx dx. Now when I'm looking at the numbers, I have 0 to 3 and I have 0 to 6. But here I have 3 to 6. So what I can do here is, how do I change it? How do I use 0 to 3 and 0 to 6 information to find 3 to 6? So that's what I need to think about. So this one, and actually this should be 0 to 6, not 3 to 6. So it should be 0 to 6 here. Okay. Now for this one, what I can do here is, no, it should be 3 to 6. Okay. So what I can do here is, I can write this as 3 to 0 g of x dx plus 0 to 6 gx dx. Now 0 to 6 gx dx, I already have this value, and this can be, I can change it, 0 to 3 g of x dx. So I got 10 minus, now 0 to 3 is negative 6, so that gives me 16. Okay, so it was 3 to 6. Now the next one is, you need to find 2 to 8 3 g of x minus 2 dx. This question is slightly different than what we did in the previous one. Now here, because the values are given for gx, okay, so what we need to do here is we need to change it into g of x. So if I want this as 3g of x dx, what is going to be changed for the limits? So if I substitute x is 8, 8 minus 2 gives me 6. So that means this upper limit has to be 6. And if I substitute, so x minus 2, if I substitute x is 8, which is the upper limit here, so that I get 6 as an upper limit. When I substitute 2 minus 2, which is the lower limit, then I get 0, which means 2 to 8, 3g of x minus 2 dx is same as 0 to 6, 3gx dx. Now, I can take this 3 out, and I already have the value for 0 to 6. Let's have a look. It is 10. So 3 times 10, which is equal to 30. So that is your final answer for this one. So in this video, we just did 2 examples, and how to use the properties of definite integral was done in one of the example. And the second one is just finding the value of the area, but using the geometrical formula. That's it for today's lesson.